Today, I'm going to talk to you about lichens, organisms that are so abundant that they often go unnoticed. They grow everywhere from sea level to high altitudes and can be found on all continents, even Antarctica. They might look like a splash of paint on a rock, colorful scales attached to twigs, miniature shrubs, or irregular patches reminiscent of mold, to name just a few forms. Sometimes you might even confuse them with a cow pie lying on the ground. Lichens come in different shapes and colors, and sometimes they can really stand out from their environment, as in the case of this fluorescent yellow-green lichen. Other times, it might be tough to find them, as they blend in with the substrate on which they grow. If you want to observe lichens, winter is a great time for it. There is much less foliage and vegetation in the way, so the lichens are less obscured. This is especially true for lichens growing on trees. But trees are not the only place where you can find them. Lichens grow on rocks, branches, soil, or many man-made objects such as benches or tombstones. They can be often found growing with or even on mosses, and that's one of the reasons people often confuse lichens with mosses or with bryophytes in general. So what are lichens, and how do we classify them? Lichen classification is complicated, as each lichen is composed of multiple organisms, each belong to a different kingdom, growing together in a mutualistic relationship. So what are the individual organisms? Let's start with the basics. The lichen's body is called a thallus. The physical structure of the thallus is formed by a fungus. Now, you're probably thinking of fungi that produce fruiting bodies called mushrooms, but not all fungi are so conspicuous. Just think about fungi that create blue cheese, or maybe that fuzzy mold covering old fruit. Those are just a couple more examples of the vast group that makes up fungi. Almost all fungi that form lichens belong to the order Ascomycetes, commonly known as sac fungi. Fungi in general don't photosynthesize and cannot make their own food, as they are, similarly to animals, heterotrophic organisms. They also cannot run around and hunt for food, so their only option is to live on another organism, living or dead, from which they suck and absorb the nutrients. A good example would be fungi growing on decomposing wood. Another option is to live in a mutually beneficial relationship with another organism, and that's exactly what the fungi and lichens do. They use photobionts, algae or cyanobacteria, which are able to use light to perform photosynthesis and create the nutrients they need for their own lives. Some species of lichen might contain both algae and cyanobacteria, in others only one or the other is present. While photobionts are busy producing the nutrients, the fungi are just reaping the rewards. If we talk about lichens as a perfect example of mutualism, but we know that all the hard work of obtaining nutrients is done by the photobiont, isn't it quite an unequal relationship? Just as the fungus wouldn't be able to survive on its own without its source of nutrients, the algae or cyanobacteria wouldn't be able to live on surfaces and in the conditions where they thrive while being lichenized. The fungus provides a cozy habitat for the photobiont to live in. It offers protection from harsh UV rays, and it keeps the photobiont moist. Imagine the lichen as a fungal body consisting of filamentous hyphae, represented by the long strips of paper here. Inside the hyphal strands is a layer of individual algal cells. The fungus provides a nice safe home for the algae, while the algae provide the fungus with nutrients. The cortex of a lichen consists of densely packed fungal hyphae, which partially obscures the color of the algae. When a lichen gets wet, the cortex is more transparent, and the color of the photobiont hiding inside is revealed. That's why lichens display much more vivid colors when wet. For many years, we believed that fungi and photobionts were the only organisms that compose a lichen. However, in 2016, scientists discovered a new organism in the cortex of some lichen species, yeast. And of course, yeasts are single-celled members of yet another group of fungi, the Basidiomycetes, adding more complexity to lichen morphology. Many questions about the presence of yeasts in lichens still need to be answered, but this just shows how much there is to explore, even in organisms we thought we knew well. However many organisms might make up a single lichen species, we know that this mutualism works very well, with each organism supporting the lichen in their own special way. Lichens are able to grow in places where other organisms are not able to survive. They are capable of photosynthesis in freezing temperatures and can survive weather extremes. They are a source of food for many animals, and thanks to their exceptional ability to rapidly absorb chemicals from the environment, they have been used as pollution monitors. There is so much more to know about lichens, and in the next video, I'll talk about different types of lichens, their colors, their morphology, and how they reproduce. If you liked this video, please consider subscribing to my channel, and I'll see you next week. Thank you for watching.